So for recursion last time, we have done the factorial, okay, and we have done the Fibonacci series. So now today I'm going to use exponential function using recursion. So you know the exponential function, ex, okay? So if I tell you, for example, determine the value of e0, what is the value of e0? It's 1. Okay, e1, 2.7 something. Okay, e3, e4. Now, we're going to write a program that is going to evaluate as the value, an approximate value of ex using recursion. Okay, so for this we're going to use what we call Taylor series. Have you heard about Taylor series? So Taylor series, it decomposes any function into like a polynomial structure, which is, I'm going to show you now an example here. So they are called Taylor series in mathematics. Maybe you're going to have this in future calculus courses. And the idea is that any function can be written as a polynomial as a function of the derivatives of that function. So let's take the very simple case of the exponential. So ex can be expressed using this function like this. It's x power 0 divided by 0 factorial plus x power 1 divided by 1 factorial plus x multiplied by 2 divided by 2 factorial and so on. So why this is like this, it's not our objective. Maybe if you're going to have this into another course, you're going to have a proof on how to derive this equation. But ex is going actually equal to this sum. It's demonstrated. So now let's assume that we would like to calculate this sum, whatever it is for ex or not for ex. So it's the sum from 0 until infinity xn divided by n factorial. Okay? So we would like to write a program that allows to evaluate this function. So how to do this? So fn, if we're going to write f, so what is f0? In recursion we have to always start from 0, from 1, from 2 and so on. And then in order to formulate our base case, and then after the base case we're going to find the general expression. So f0 is going to be equal to not 1, but it's x power 0 divided by 0 factorial. So I'm going to write x power 0 divided by x or 0 factorial. So f1 is equal to what? X power 1 divided by 1 factorial. No, it's equal to this one, the sum. So we can write this is equal to f0 plus this new one. صح ولا لا؟ صحيح ولا مش صحيح؟ مش واضح؟ Okay, now if I want to make f2, what's the value of f2? So it's going to be all of this sum plus this is 2 and this is 2, which is equal to what? f1 plus this. So if we write down several times, we can write fn equal to what? fn minus 1 plus x power n divided by n factorial. Can we do this using recursion? Okay, a recursion, what is a recursion? It's a function that calls itself. So if you remember here in factorial, we did it in recursion. We define the base case. Why we need the base case? To exit from the function. Otherwise, it's going to have an infinite loop. Okay? And then, if you remember, we're going to return, okay, fn is function as fn minus 1. So it's the same principle. Now here, if we're going to write the exponential, okay, if we're going to write the exponential, let's write the function public static double my exponential, okay, or the expo. So what parameters is going to take here? So it's going to take in n, okay, because this sum, as you can see, so the sum goes to infinity, but we cannot go to infinity. We have to stop. Maybe we stop at n equal to 10 or n equal to 11 or 20. So we have to make certain number of iterations. What else for the function? We need to define x. We're going to calculate exponential of x. So you can see here, I have x and I have n. So two parameters. What is the base case?
N equals 0.
What is the base case? If n equal 0, what to return? Return صح ولا؟ Because this is 1, x power 0 is 1 and 0 factorial is 1. So this is the base case and we are done. So if it is not 0, what we should do? Return what? We call the function itself expo, the same x and minus.
يسوي n minus 1
الآن yeah plus what؟ لأنه تساوي قلنا fn minus 1, so it's this one plus so x, how to make the exponential? It's math dot exponential of math, no, not exponential, power dot power. So power, what is a?
6.
Raised to the power of the second argument. The first argument is x, so the first element is x, and the second is n. Divided by, so here we have to have the factorial of n. Do we have factorial here? So we're going to use our factorial that we did before. I'm going to bring the factorial that we did before. Okay. I'm going to bring this factorial because we will need it. We will need the factorial divided by r factorial. So let me call it factorial. This is better. Factorial of what? Of n. واضح? Okay, now we would like to make the testing of this. So how to test? how to know that now this is going to give an approximate value of Ex. So I have to compare the value of Ex, the real value of Ex, with the value that I get with this approximation. لأن هذه قيمة تقديرية صح ولا لا؟ الآن what we are calculating, this sum, it's an approximate value of the real value of Ex. Okay, ليش السام هذه أنا شغل mathematics. لكن now we take it as an assumption, which is correct by the way, and it's proved. Okay, so what we can do here, we can write public static void main string args, and now we can print approximate. So let's make double approximate Ex is equal to what? Expo. So I'm going to define double X مثلا 3 X equal 3.2. So I'm going to call my function with the value of X, and I'm going to define int. So how many iterations? Let's say 10, and we can change these values later. So this is 2.3 or 3.2, and this is okay, this is X, and this is N. So this is an approximate value. Exact Ex. How to get the exact value of Ex? Math dot exponential of X. Okay, so now I can have approximate exponential value is what I should put here, this one, and then I'm going to put the exact value. Okay, and I can also print the difference or the error between exact and approximate, between exact and approximate. How to find? Minus this one. واضح? Okay, so now which one? Factorial. Okay, so now everything is working fine. This is factorial. No, it's not, it's this one. You can see now. Okay, I think I have to disable this one because I don't need. Now I'm going to execute. The approximate value is this, and the exact value is this one, and this is the difference. Is it a good approximation? Yes. So we can see now, if I put n, if I put n larger, what will happen for the error? This is too much. I'm going to put 20. It's 9 exponential minus 10. So very, very, very small. You can see they are almost equal. So you can see now this approximation is very good. Okay, even with 20 iterations, we are able to find, and we can apply this to different kind of functions. Now, for example, in the previous major exam, in the previous final exam, there is another function, okay, which is this one. Okay, this is another function. It's the same principle. So you need to think this. If you want to apply, watch this video again. Okay, and it's a function 1 divided by 1 minus x squared. So this one we can approximate by a sum n multiplied by x n minus 1. For x, absolute value of x smaller than 1. So it's between minus 1 and 1. X must be between minus 1 and 1. So this is a condition that you have to check. You can use recursion. So what is the base case here? What is the base case for n equal to? Diamond base case for n equal to 0. Okay, so for n equal to 0, what's going to be the value? N multiplied by x n minus 1. 0 multiplied by x minus 1 كم تصبح؟ صفر لما تضربه في عدد آخر كم يولي؟ الحمد لله. صفر base case. Now if x equal to 1, then we find the value. If n equal to 1. 1. So we have two base cases that are available for us. For n equal 0, it's 0. For n equal 1, it's 1. And for all the others, we're going to make a recursion, okay, in the same way that we did now for exponential. Okay, I will send you 2 or 3 more exercises with solutions, and you have to, because you're going to have something similar to this one. And usually in the final exam, I will give you something like the following. So in order to make sure that your work is correct, so in the final exam, you're going to have a file which contains a function with a missing code that you have to write. And below here, there is a test case. So when you write your function, okay, you can compare, and you can also compare with the error. So if your function is correct, you should have a very small error. And at the end, you have to print the output that you get from this one. So same thing, you define f, okay, using recursion. This is f using the real value, the real function like we did with exponential using math.pow here, okay. And then we're going to make a test case that allows to compare between the two different functions. The one that is approximated and the one that is the real value. Math.x, it's a built-in function, right? And math.pow, it's the power, it's a built-in function also in Java. Okay, so to summarize, we did a recursive function for the exponential function, okay, based on the Taylor series. We have f0 is equal to 1, f1 is equal to f0 plus x power 1 divided by 1 factorial, and finally we come to the general case fn equal to fn minus 1 multiplied by xn divided. درستوهم السيريز أظن في الماث. درستوا series function. series function. This is a series function. يعني there is nothing different.
دكتور الجنرال كيس دائما هي اللي بتيجي بالاختبار صح؟ لازم تكون واضحة.
For you, you're going to have a formula like this. This formula, or like the formula that I have shown to you in the previous final exam, something like this.
The general case is if x equals 1.
Yeah, you're going to have this, the math expression. So from the math expression, you have to find the base case, and you have to find the general case, which is already in the equation, okay? And then write your recursive function. Usually it's 2-3 lines of codes, no more than this, okay? quite simple. Now we have at least 3 examples on recursion, okay, which is going to be very useful for you to grasp this concept. Any question? Okay, that's all for today.